Okay, everybody, welcome to video lesson number 3. Hopefully you all had a really great weekend and you're all healthy. Our guest today is Knight in Shining Armor. See this guy? I raided my kid's toy closet, as you can tell. I figure he could be like smashing out the virus. See? All right, it's corny, sorry. Okay, here we go. Notes. Remember that you can either print these notes out from the link, or you can just do it on a regular piece of paper. Or, third option I came up with, I have a box down in the lobby of the school where I can put these copies of these in here. So if you're near the school, you could just stop by and get a copy of it. Any way you want to do it is fine, just as long as you have your notes, because when we come back to school, you're going to turn them in. So don't forget your notes. Okay, first thing we're going to do is review from lesson number 2, the distance formula. So find the distance between 2 points. Now, if you look up distance formula online, you're going to get this scary formula that looks like this. Distance equals square root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And it looks pretty complicated when you look at it like that. But just remember, this is also known as the Pythagorean theorem. So put AKA Pythagorean theorem. Okay, because this first part right here where we're subtracting the 2 x's, this just makes your horizontal leg. Horizontal leg. And this part right here where we're subtracting the 2 y's, this just makes your vertical leg. So there you go. It's much easier if you think about it as a Pythagorean theorem. So I like to write it like this instead of this. I like to write the distance equals square root of leg squared plus the other leg squared. To me, that's much easier to figure out. Okay, so in your homework, you were given 2 points, and you were asked to find the distance between those 2 points. So let's just go ahead and plot this out. So this 0, 4 would be right here, 0, 4. And this one is at 2 and 3, over 2 up 3. And they're actually not very far apart at all. They're close. Okay, so let's do this using the distance formula. So let's do the horizontal leg first. So we're going to take that x, we're going to take that x. The big number minus the small number. So 2 minus 0 is still a 2. So our horizontal leg equals a 2. And you can see that up here if you draw this out. If you make the horizontal leg, you can see that that just goes 2 squares. Okay, let's do the vertical leg. So we're going to take our 2 y values, the big one minus the small one. 4 minus 3 equals a 1. So our vertical leg equals a 1. And if you were to draw that up there, you can see the vertical leg really is a 1. All right, but we're really looking for this diagonal piece. So that's where the Pythagorean theorem comes in. So the distance equals square root of leg squared plus leg squared. So 2 squared plus 1 squared equals square root 2 squared plus 1 squared equals 2.23. We are rounding to the nearest tenth, so it's still just 2.2. Okay, here's another thing I want you to notice. If you had this picture and I asked you to find the slope, you would just count it. You would say, okay, well, that's a negative slope, so I go down 1 over 2. So you would write m equals down 1 over 2. And notice the slope numbers are exactly the same as the leg numbers. They just correspond to each other. Okay, so that's the review from lesson 2. Now we're moving to lesson 3, and here we're going to be talking about parallel lines and perpendicular lines. And we've done this already this year, so this should be a bit of a review. Okay, essential question number 3. How can we tell if two lines are parallel or perpendicular or neither to each other? So how can we tell if two lines are parallel, which would look like that, or perpendicular, which means they cross at a 90-degree angle, or neither? Maybe they just do something like that to each other. And the answer to that question is we're just going to use the definitions. Okay, page 2. Okay, like I said, this is a review. You guys should be good at this. So parallel. Two parallel lines have the same slope, but they must have a different y-intercept. So for example, let's say on this graph our y-intercept is a 2. So put b equals 2. Remember, y-intercept is designated with a b. The slope, let's say we're going to go up 1 over 3. Slope is designated by an m. Slope equals up 1 over 3. And if I can draw a straightish line. Okay, here's our first line. Now, if we want one that's parallel, it's got to have the same slope, but a different y-intercept. So let's have this next one start at a -1. So let's say b equals a -1. But our slope has to be the same, up 1 over 3, up 1 over 3. There you go. Two parallel lines. Same slope, different y-intercept. Now remember, the reason they need a different y-intercept is to spread these two lines apart, because we don't want the lines right on top of each other. That wouldn't be parallel. We need to spread them apart. Okay. Now let's talk about perpendicular. Hopefully you remember this. Two perpendicular lines, the slope is the opposite inverse. So opposite means if it starts out negative, you're going to change it to a positive. Or if it starts out positive, you're going to change it to a negative. Inverse means you're going to flip it. So here would be some examples. If I started out with 1 over 3 and I wanted perpendicular, this is positive, so perpendicular have to be negative. Negative, flip it, 3 over 1. Thing is, we don't really write the over 1 part because it's not necessary. So just negative 3. Let's say you started with a negative 7/2. If you want the perpendicular to that, you have to take the opposite. So now we have to have a positive, and we have to flip it to 7ths. Okay, here's another example. Let's say you're given positive 4. So you need the opposite, so you need a negative. Remember, this is a 4 over 1, even though we don't write it, so you've got to flip it. 1/4. Okay, there's 3 examples for you. So let's draw this on this graph. Let's start with the same that we had over here. With the intercept at 2 and a slope of up 1 over 3. Up 1, 1, 2, 3. Okay. Draw a straightish line there. All right, now my perpendicular one, it doesn't matter where I put the intercept. I'm just going to put it at the same place. So b equals -1, which is right there. But the slope has to be an opposite inverse. So this one was positive. It's a positive slope. Now we have to do a negative slope, and we have to flip it. So -3 over 1. So start from your intercept, go down 3 over 1. You can also do it the opposite direction. Up 3, backwards 1. I think I could better get a ruler to draw this one. Make sure it's straight enough. There you go. If you counted it right, your 2 lines should definitely cross at a 90-degree angle. One of them's positive, one of them's negative, and they cross exactly at 90 degrees. Okay, kind of looks like Christmas on that paper. All right, so here's some example problems you're going to run across. If it's already in slope-intercept form, this is going to be easy because you don't have to do extra work. They're just going to give you the equation, y equals 6x minus 1, and they want to know what a parallel slope would be. Well, that would be exactly the same. So slope would have to equal 6, because there's your slope. But a perpendicular slope has to be the opposite inverse. So this is positive, so it's going to have to be a negative. Remember, this is really 6 over 1, even though they don't write it with the over 1. So when you flip it, it's 1 over 6. Okay, you'll have several like that. Then you're going to come across a few that are in standard form. Standard form is a little more work because we need to switch it around until it's in the slope-intercept form so we can tell what the slope is. So, but that's not hard. You guys have been doing that for a while. So here we go. We're going to switch this around. I'm going to subtract 6x from both sides. So I have -9y equals -6x minus 6. And divide everything by a -9. So now I have y equals, remember 2 negatives make a positive. So I have 6 over 9x. These 2 negatives make a positive, plus 6 over 9. And that definitely can be reduced because both of those numbers can be divided by 3. So really, it's y equals 2 over 3x plus 2/3. So see, that's where you had to do a little bit more work because you had to switch it. All right, now what's the parallel slope? Well, it's exactly the same, 2 over 3. Perpendicular slope has to be an opposite inverse. This one's positive, so this one's negative, and then you have to flip it, 3 over 2. Okay, you'll have a few problems like that. Then you're going to get one like this, where we've only got points. And we have to figure out what the slope is. So the way I like to figure out slope is by using a t-chart. I know I've told you guys this before. And remember, when you're doing this, you have to do the changing y over the changing x. That's how you figure out what slope is. Okay, so I'm going to take the first one. I'm going to number these. This is number 1 right here. Number 1. So we're going to put the numbers in here. A 0 and a 4, a 6 and a negative 4. How much is that changing? If you go from positive 4 clear down to negative 4, you're going down 8. And on the x side, if you go from 0 up to 6, you've gone up 6. So our slope equals, remember the y change has to go on top, negative 8 over 6. Since both of those can be divided by 2, I know it can be reduced to negative 4 over 3. So number 1 right here, the slope was negative 4 over 3. Okay. Let me get a different color marker. Let's do blue. Okay. Second one right here. Make my t-chart. I'm going to go 8 and 7, and negative 4 and negative 2. And if I'm at 7, I have to go clear down to negative 2. That's 7 and 2 more. So that's down 9. This one, if I'm at 8, I have to go clear down to negative 4. It's 8 and then 4 more. So that one's down 12. Remember, the y change has to go on top. So the slope of this one is negative 9 over negative 12. I can reduce that because 2 negatives make a positive, and both of those can be divided by 3. So we really have 3/4 on that one. Okay, so slope number 2 right here was 3/4. And if you notice, these two, slope 1 and slope 2, are opposite inverses of each other. So these two are perpendicular. Okay, good. Let's do number 3. Let's try this orange color. All right, kind of out of room. Guess I'll stick it right here. So let's see, we have a negative 4 and a negative 5, 4 and a 1. If you're at negative 5 and you're going up to 1, you've gone up 6. If you're at -4 and you go up to 4, you've gone up 12. Remember, the y change goes on top. So the slope equals 6 over, whoops, that's an 8. Apologize. I don't know how I came up with 12. -4 to +4 is an 8. 6 over 8. That looks better. Both of those can be divided by 2, so it's really 3 over 4. So I'll go back over here. Slope number 3 was up 3 over 4. Those two are exactly the same as each other, so those two are parallel. Okay. Homework. Your homework is on ALEKS this time. It's called Lesson 3. If you want full credit, you're going to have it done by April 3rd, which is Friday, at 3 o'clock. Otherwise, it's not a deadline until midterm. So this video is over unless you're in the honors class. If you're in the honors class, there's one more section. So, honors kids, one more page. Here we go. So, we're gonna see if you can remember the point slope form. Here it is. Y equals slope x minus x sub 1. Remember, that doesn't necessarily mean minus, it means opposite. Plus y sub 1. So here would be an example. Say you have a slope of 1/2, and they say it goes through the point -2, 3. Here's how you would write your equation. You'd write y equals, the slope is 1/2, x, this is opposite, so instead of a -2, you're going to put +2, plus 3. That's how you're going to work that out, point slope form. All right, so on your homework, you're going to see a few problems like this. Consider the line y equals -9x plus 9. They want you to find the equation of the line that is parallel, so we have the same slope, but it's going to pass through this particular point, 4 and 6. So you're going to use your point slope form. So you've got y equals, your slope is the same, -9. Then you're going to go x, we want the opposite of this 4, so -4 plus 6. Okay, equation of the line. Let's keep going. Let's distribute the -9 through there. So y equals -9x plus 36 plus 6. Remember, negative times a negative is a positive. Combine like terms, we're going to get y equals 9x plus 42. There you go. That's how you need to answer it on ALEKS. Okay, so let's do one that's perpendicular instead of parallel. Same points, same beginning equation. So y equals an opposite inverse slope. Instead of negative, you want a positive, and then you need to flip it. So 1/9, parenthesis, x minus 4 plus 6. Distribute. Y equals 1/9x minus 4/9 plus 6. You can do that on your calculator. You can do it in your head. Because we need to combine these like terms right here. 6, it needs to have a 9 on the bottom. So 6 times 9 is 54/9. So I'm going to write it like this. Y equals 1/9 x minus 4 over 9 plus 54 over 9, because now I have the same denominator, so I can add them together. Final answer, y equals 1 over 9x plus 50 over 9. Okay, good luck. Hope you have a great time doing it. Say goodbye to the knight in shining armor. See ya.